Hello, I'm Vaibhav Pujari and today we'll be learning about DBMS Unit 1 Introduction Database. So first let's understand about what is the meaning of data. Data means known facts that can be recorded and that have implicit meaning. Database is a collection of related data. For example, considering the names, telephone numbers and addresses of the people you know. You may have recorded this data in an indexed address book or you may have stored it on a diskette using a personal computer and software such as DBMS 4 or 5, Microsoft Access or Excel. This is a collection of related data with an implicit meaning and hence it is a database. What is DBMS? DBMS is Database Management System, a collection of programs that enables users to create and maintain a database. The DBMS is hence a general purpose software system that facilitates the processes of defining, constructing, and manipulating databases for various other applications. Now, the DBMS allows users the following tasks: data definition, data updation, data retrieval, and user administration. Now, what is user administration? It is used for registering and monitoring users, maintain data integrity, enforcing data security, dealing with concurrency control, monitoring performance, and recovering information corrupted by unexpected failure. Database systems versus file systems. So traditionally when we used to save data, we used to save in file systems. So one way to keep the information on a computer is to store it in an operating system files. To allow users to manipulate the information, the system has a number of application programs that manipulates the file. Keeping organizational information in a file processing systems has a number of major disadvantages like data redundancy and inconsistency, difficulty in accessing data, automaticity problems, and security problems, etc. Now, what's the need of database management system? The first one is the ease of accessing data. In the file system, different files are created for each user containing which data they can access. Also in the file system, for the user to extract data, there is a need for code or application. DBMS removes redundancy by granting access to users and decides which and how many parts of the data is accessible to them from the database. Second is the storage and management of data. Data cannot be stored in the form of objects in the file system. DBMS, the data can be directly stored in the form of objects. Ease and efficient file management, where in DBMS, where the objects are indexed based on the attributes of the data, while in the file system, the entire database runs for every query operation as files are indexed. Avoiding duplicates and redundancy. Data normalization is used in DBMS to avoid duplicate data. Concurrent data accessing. Users can access data simultaneously through different applications. In file system, this simultaneous access leads to inconsistency, while in DBMS use ACID approach to tackle the issue. Now, what is ACID properties in DBMS? In ACID, A stands for atomicity. The entire transaction takes place at once or doesn't happen at all. C stands for consistency. The database must be consistent before and after the transaction. I stands for isolation. Multiple transactions occur independently without interference. D stands for durability. The changes of a successful transaction occurs even if the system failure occurs. What are the advantages of DBMS? It controls database redundancy. In DBMS, the authorized users of an organization can share the data among multiple users. This is called as data sharing. Easily maintenance. It can be easily maintainable due to the centralized nature of database system. It reduces development time and maintenance need. It also provides backup and recovery subsystems which create automatic backup of data from hardware and software failures and restores the data if required. Multiple user interface. It provides different types of user interfaces like graphical user interface, application programming interface, etc. Database system applications. The database management systems can be used in various fields, for example, banking, airlines, universities, telecommunication, finance, sales, manufacturing, and human resources. Data abstraction. For the system to be usable, it must retrieve data efficiently. The need for efficiency has led designers to use complex data structures to represent the data in the database. Since many database systems users are not computer trained developers, hide the complexity from the users through several levels of abstraction to simplify users' interactions with the system. We have three levels of abstraction: physical level, logical level, and view level. The lowest level of abstraction describes how the data are actually stored. The physical level describes complex low level data structures in detail. The next higher level of abstraction describes what data are stored in the database and what relationship exists among those data. Third is the view level. The highest level of abstraction describes the only part of the entire database. These are the various database management system terminologies. Data independence. It is defined as a property of DBMS that helps you to change the database schema at one level of a database system without requiring to change that schema at the next higher level. Instance. Database change over time as information is inserted and deleted. The collection of information stored in the database at a particular moment is called as an instance of the database. Third is the schema. The overall design of the database is called as database schema. DBMS architecture. There are three types of DBMS architecture: 1-tier architecture, 2-tier architecture, and 3-tier architecture. 1-tier architecture. In 1-tier architecture, the database is directly available to the user who can directly sit on the database and use it. For example, the client, the server, and the database all present on the same machine. Next is the two-tier architecture. The two-tier architecture is similar to a basic client-server model. The application at the client end directly communicates with the database at the server side. APIs like ODBC, JDBC are used for the interaction. Third is the three-tier architecture. In this type, there is another layer between the client and the server. The client does not directly communicate with the server. Instead, it interacts with an application server which further communicates with the database system, and then the query processing and transaction management takes place. Now, what are the advantages of using three-tier architecture? Enhanced scalability due to distributed employment of application servers. Data integrity is also maintained and security is improved. Thank you.